For part 2, we're going to take a look at series, particularly what we call summation notation. Now, what a series is. A series is nothing more than the sum of a sequence. In other words, let's take a look at an example. Let's say we have the following sequence. 1, 2, 3, 4, 5. That's a sequence. A series is what happens when you add them all together. And what is 1 plus 2 plus 3 plus 4 plus 5? Now there's a shortcut. We're going to talk about that later on, but the answer is 15 in this case right here. Check that. My arithmetic is always terrible. All right, now, instead of writing it out like 1 plus 2 plus 3 plus 4 plus 5, we do have a very nice way to show how we can write the sum of a sequence without listing all the terms of the sequence. It is called either summation notation or what we call sigma notation. Now, we use the Greek letter sigma. It's an S. It doesn't look like an S. This is the Greek letter sigma. It actually looks like an E, but it's the Greek letter S. Sigma, S for sum. All right, so we're going to take a sum, and how we notate this is very simple. It's going to be I from I at the bottom, I equals 1 or 0, where we start, to some number B. Okay, and sometimes we just go from A to B. We'll worry about the 1 to 0 in just a little bit. Of f of x sub I. Now, or maybe like this. I equals from A to B of a sub n of I. The I just stands for the ith term. So basically what it says is find the sum. This is what it says to do. Find the sum of the sequence a sub n from I equals A to I equals B. And that's what it's saying to do. And it looks really weird like this, so let's take a look at an example. Might make it a little bit clearer. We want to find the following sum. There's my sum. So it says start with the first term, go all the way to the sixth term. We want to find the sum of 6 terms here. So we let I equal 1. Now if I let I equal 1 just from yesterday, just plug that in. 3 times 1 minus 1 is 2. Let I equal 2. So we're going to go from I equals 1 all the way to I equals 6. If I let I equal 2, we get 5. I equal 3. 8. I equal 4. 11. I equals 5. We get, what's that? 14. And we got one more. I equals 6. 18, it becomes 17. So this is my sequence. 2, 5, 8, 11, 14, 17. But the sum, the sigma, means I have a series. And if a series means to add everything together. So to make the sequence a series, we add these all up together. So what's 2 plus 5 plus 8 plus 11 plus 14 plus 17? Real quickly, verify that, 57. So let's take a look at number 2 here. It says let I equal 1 to 5. So let's go ahead and do that one. I equals 1, I equals 2, I equals 3, I equals 4, I equals 5. What's kind of cool on this one, there's no I here. So we talked about this yesterday. This is just a sequence 5, 5, 5, 5, 5. Like the birds from Nemo. Mine, 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 mine. 5, 5, 5, 5, 5. And all I'm going to do now, there's my sequence. To get the series, we add them. This sigma notation means it's a series. We got to add the terms. That's what it means to do. Plus 5, plus 5, plus 5. This is kind of easy. 10, 15, 20, 25. Very good. There's our summation. All right. So let's try number 3 here. Ooh, fractions. I hate the word. All right. But this time we start at I equals 2. We go all the way to I equal 4. So I equals 2. I equal 3, I equal 4. Plug it in. 1 over 2 cubed, that's me, is 8 minus 1, 7. 1 over, what's that become? 26. Keep going. I equal 4, we get 1 over 63. And now we're going to add those together. Now I'm going to use my calculator here because I really can't do those in my head. I get, clear that out, 1 divided by 7 plus 1 divided by 26 plus 1 divided by 63. Enter, ew, nasty, but change it to a fraction. Math, fraction. 323 over 1638. Ugly. All right, what I would like you guys to do is see if you can try number 4. Be careful, we have that negative. That means something. It's going to alternate. Now, next year in calculus, series and sequence are very big for us. We have to learn how to write these, okay? And that's what we're going to take a look at right next year. How do we write using sigma notation? Really, it's look for the pattern. The tops are staying the same, but the bottom equals 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, dot, dot, dot. This means we can go all the way up. This means we're going to go from 4 all the way to include the 15 is where we stop. Now, I always tell students, why do we call it a variable? Is because it is the one changing. That's what gives our variable. Constant, 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 change, 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 change. So these are changing. Those are our variables. And the only variable we use here is I. Those are our i's. So I could write this as 5 over 1 plus I. Now, I'm adding them. Now, if this were a sequence, if this were just a sequence, it would be a sub n equals 5 over 1 plus I. But this is a series. We know it's a series because we are adding terms together. So because it's a series, I'm going to take my sequence and add them all up. And I'm going to start I equals, well, what was my first I? 1 all the way to, that's my first I. That's our first I. And I go all the way to here to my last I, which is 15. And there's our answer for this one. All right, so take a look at these if you need to again. These are very easy to do, and we're going to take a look at some practice tomorrow.